Okay, let's unpack this. We've all seen it, right? The news coverage, year after year, a firestorm, a hurricane, some massive flood hits a community, and what's the very first thing that happens?
Oh, they rush to rebuild.
Exactly. They rush to rebuild, often using the exact same methods, the exact same wood, the same materials that failed spectacularly just moments before. It's just a frustrating cycle, a repeating failure.
It really is. And the deep dive we are launching into today, it's centered around a system that basically promises to break that cycle completely.
Okay.
We're analyzing the Lifestone building system. It actually originated under the name Gigacrete. And look, it makes an extremely bold claim.
Which is?
That they can build structures designed to withstand, well, virtually every natural calamity you can think of. We're talking fires, floods, earthquakes, tornadoes,
Wow.
and winds that go far beyond, the official limits of the Saffir-Simpson scale.
Yeah. Okay, that is bold. What's truly remarkable, though, or what sounds remarkable, is they claim this extreme resilience, this engineering complexity, with an equally extreme simplicity.
That's kind of the core idea.
Their pitch is that the entire main structural shell of a home is built using only 3 basic components. Is that right?
That's the genius of it, or at least the claim. It's an engineered solution where the structure is boiled down to just 3 elements: steel, foam, and then these proprietary coatings.
Seal, foam, coatings. Simple.
The aim is to create structures that aren't just disaster-proof, but also allow for extremely fast construction and, crucially, deliver a lower cost of ownership over the structure's lifetime.
All right, let's look at the skeleton first then. The steel, they use cold-form steel, CFS.
Right.
Now, for anyone thinking this sounds maybe experimental, CFS is actually century-old technology.
Yeah, it's been around.
We're talking a proven material used since, what, the 1885 Home Insurance Group building in Chicago?
That's the one.
But the sources, they provide this staggering claim we have to acknowledge. They say no steel-framed residential building has ever been destroyed by high winds.
That is a phenomenal data point, isn't it? Especially when you think about the strength, the tensile and compressive strength. That's just inherent in the material.
Right.
The steel they use, it offers a yield strength between 36,000 and 50,000 psi.
And what does that mean in real terms? 36,000 psi sounds like a lot.
It is. To put that in perspective for you, 36,000 psi is roughly like taking 18 tons of pressure.
18 tons.
And compressing it onto 1 tiny square inch of material. That's serious foundational strength we're talking about.
Okay. But steel, it has those 2 classic drawbacks in home building, right? Rust and thermal bridging.
Absolutely. The way metal conducts heat and cold straight through the wall.
Yeah, killing your energy efficiency.
Yeah.
So how does Lifestone get around those?
Well, they mitigate both through the actual system design. Rust is managed pretty simply. The steel is galvanized.
Coated in zinc.
Yep. Coated in zinc. Provides a long-lasting barrier against corrosion. And the thermal issue, that's addressed structurally.
How so?
The steel framework is completely encapsulated. I mean, every single post, beam, truss, it's all sealed inside.
Inside the second component.
Exactly. By the second component,
Yeah.
the EPS foam.
Ah, the foam. Expanded polystyrene.
Okay.
Okay, when you hear foam, I think most people think insulation, maybe packing peanuts.
Right. Not structure.
You certainly don't typically think structural.
Exactly. But this foam, it actually serves dual purposes here. First, yeah, insulation. It's 98% air, so it's highly insulative. Delivers an R value of about 4 per inch.
Okay.
But since the walls are so thick with this system, you end up with total wall systems rated at R40, sometimes even R47.
R40 to R47.
Now,
Compare that to a typical stick-built house in the U.S.
Yeah.
What, R13,
Yeah.
maybe R19 if you're lucky?
If you're lucky, yeah. It's a massive energy difference. Huge.
Okay, so insulation is one function, and second, a structure. This is the part that genuinely surprised me when I was reading the source material.
Right.
The EPS foam itself is actually load-bearing. The claims state that on its own, this foam can hold 4 tons of pressure per square foot.
4 tons. It's incredible. We're talking about foam that's strong enough to literally replace fill dirt under highway on-ramps.
Wow, that completely changes the definition of filler material.
It absolutely does. And another crucial point. The foam is non-organic.
I mean,
Unlike wood or gypsum board, it just cannot support mold or mildew growth. That's a major health concern and a degradation issue, especially in humid or flood-prone places.
good point. Okay, steel frame, foam insulation, and structure. Now we get to the skin, the exterior and interior finish. The coatings. These are proprietary stone-based finishes, And they replace both drywall inside and traditional stucco or siding outside.
Yes. They call them StuccoMax for the exterior and PlasterMax for the interior. And these are unique because they're primarily limestone calcium carbonate.
Limestone. Okay.
And they specifically bypass the use of Portland cement. That's actually a huge sustainability point because cement production is notoriously CO2 intensive.
Right. Huge carbon footprint with cement. And the mechanism here is clever, too.
Yeah.
They skip traditional sheathing, like plywood or OSB, and also plaster lath.
Because the coatings are designed to uniquely bind directly, almost molecularly, you could say, to the EPS foam.
So it becomes one solid, monolithic shell.
Exactly. And the sources, they offer this incredible data point on the waterproofing aspect.
A head pressure test.
That's the one. To demonstrate water resistance, they set up this factory test rig back in 2012. It's apparently still running today.
Still running.
Yep. Applying 6 feet of constant water pressure against the coating. And after more than a decade, no failure.
Wow.
That gives you a physical, long-term proof point that this shell is really designed to keep water out.
6 feet of pressure running since 2012.
Okay.
That moves us perfectly into these claims of extreme resilience. Let's tackle the biggest one first, the Cat 6 name.
Right. We definitely need to be clear here. Category 6 is a coined marketing term.
Not official.
Not official at all. It's not part of the Saffir-Simpson hurricane wind scale, which, maxes out at Category 5.
Okay, so what does it mean then?
It means this structure is engineered to withstand verified wind speeds of up to 250 miles per hour.
250 miles per hour. That is significantly beyond even a catastrophic Cat 5 storm.
Way beyond.
That sounds like building a vault. How do they physically lock the house down to resist that kind of incredible uplift? Because, in a high wind event, the roof tends to be the first thing that fails, turns the whole house into a parachute.
It does. The mechanism they use is, it's elegant in its brute force, really. It involves what they call an all-thread rod.
Okay.
Think of it not as a standard bolt, but as this giant, continuous threaded steel rod, about 1 inch in diameter.
An inch thick. Wow.
And this rod runs secured from the roof structure down through the actual steel wall posts and then deep into the concrete foundation.
So it literally ties everything together.
It essentially staples the entire structure, roof, walls, foundation together as one single solid unit.
Okay, so uplift is defeated. Now let's talk about water. The increasingly common issue of flooding, even outside traditional floodplains, Drainage systems get overwhelmed, new developments change runoff patterns.
Yeah, a major, major concern. And this is where the non-organic nature of the structure really pays off instantly.
How so?
Well, if a home built at ground level floods, let's say, with 8 feet of water, a traditional wood frame house, that's often a total tear out.
Because of mold, mildew.
Exactly. Mold, mildew, decomposition of the organic drywall, the insulation. It's a mess.
But here, with Lifestone.
Because the Lifestone walls are non-organic and waterproof, the walls themselves won't decompose or need replacement. Now, you definitely lose your furnishings, of course.
Sure.
But the walls themselves, they could simply be sanitized. The electrical cables would likely need replacing, but they can be pulled easily through those existing factory-cut channels. You salvage the actual structure, which is the most expensive part of the home by far.
That's a huge difference. And what about homes raised on pilings? In coastal zones, designed for storm surge. The sources mention using breakaway walls. What's that about?
Right, breakaway walls, absolutely critical. So when a storm surge hits a raised structure, the sheer force of, say, an 8-foot wave can exert hundreds of thousands of pounds of pressure on a solid wall.
Which could knock the whole house over.
Exactly. It could topple the whole thing. So instead of resisting that immense pressure, breakaway walls are designed to fail intentionally. They literally break away, allowing the water and debris to pass through the lower level.
Ah, so the force goes through, not against.
Precisely. The main house structure, secured by those all-thread rods we talked about, stays intact up on its pilings. It's just intelligent engineering for survival in those specific zones.
Okay, that makes sense. Now, if natural disaster resilience wasn't enough, we discovered there's an option to upgrade the coating for extreme security. We're talking about something called ballisticrete.
Correct. Yeah, this is an upgrade where they apply a thicker version of the coating mixed with special fibers, and it's certified bulletproof.
Bulletproof, like actually.
Actually.
Yeah.
NIJ certified. It's been tested against serious high-caliber fire, including .50 caliber rounds, AK-47 rounds.
Oh.
It's an option suitable for, high security applications, maybe safe rooms within a house, or even integrating certified ballistic protection into the entire exterior of a home or, say, a school.
Integrating it into the whole house. That level of security built right into standard residential construction is, well, it's pretty unique.
It really is, turning your home into a virtual bunker, essentially.
It's astounding.
Yeah.
But this raises the question, if the material science is this solid, how quickly can they actually deploy this? How fast can they build using this system? Let's shift focus to logistics and construction speed.
Yeah, good question. And it's important to clarify first, this is not a prefab home, meaning they don't ship a fully assembled module on a flatbed truck. It's what's called a panelized system. Components are precision machined in a factory, they're labeled, and then they're shipped in standard shipping containers.
Right, the logistics of that seem key. They claim, what, a 1,500 square foot home can have its core components shipped for around $15,000.
That's the figure mentioned, yeah. And everything arrives on site, ready to be slotted together, almost like a massive three-dimensional puzzle.
Which leads directly to the assembly advantage.
Exactly. Because of that precision machining, which basically bypasses all the traditional variability and, frankly, errors you get with on-site cutting and measuring, they claim the main structure can be erected by general labor.
Not specialized crews.
General labor, just overseen by one trained site foreman. And the speed, they claim, is about 1,500 square feet per day.
1,500 square feet of structure assembled in one day.
That's the claim. It's remarkable if achievable consistently.
So what's the target total build time then? From getting the permit to getting the certificate of occupancy?
They target 120 days.
4 months. That's significantly faster than most traditional construction, especially for custom builds.
It is. But that speed, it really hinges entirely on how they manage the integration of utilities, the MEP systems. Mechanical, electrical, plumbing.
Right. Running electrical wires and plumbing pipes through these thick R40 foam panels sounds like it would be a major headache. How do they handle that without compromising the shell's integrity?
This is where the engineering, again, really shines. For electrical systems, it's pretty straightforward. The channels, the pathways for the wires are actually pre-cut at the factory right through the foam panels.
Ah, so they're already there.
Already there. Electricians are basically just pulling cables through existing channels. There's no need to drill or cut new holes through steel studs or compromise the structure.
Okay, so electrical's easy. What about the bulkier stuff? Plumbing, waste lines, supply pipes. They need wider, deeper channels.
Right. For plumbing, they use a specialized tool on site. It's called a hot knife.
A knife?
Yeah. Plumbers use this tool to gently melt and cut the necessary channels for the pipes directly into the EPS foam right where they need to go.
So you're melting a path, not cutting through steel.
Exactly. Once the pipes are installed, the channels are simply sealed up with spray foam before the final interior PlasterMax coating goes on. It's entirely non-invasive to the actual structural integrity of the steel frame.
Okay, that's clever. So we have exceptional speed, incredible resilience, smart utility integration. Sounds amazing, but with all this precision and the need for all the components to be delivered right away, there must be a significant logistical hurdle somewhere, usually for the homeowner.
There is.
What's the financial trade-off for this rapid engineered deployment?
That is the critical constraint, and you nailed it. It's financial flow, cash flow.
How so?
See, in a traditional build, you usually pay a small deposit, and then the bank releases funds, makes draws as specific milestones are hit. Foundation poured, framing up, drywall done, etc.
Standard construction loan process.
Right. But because the Lifestone system requires all the materials to be precision machined and paid for up front.
To enable that rapid 120-day build schedule.
Exactly. Because of that, the company demands a much higher upfront down payment. The sources say in some cases, up to 50% of the total build cost is required right after the permit is submitted.
50% upfront. Wow. That is a significant barrier. That immediately limits accessibility for buyers who rely on those traditional construction loan draw schedules.
It does. It's basically the price you pay for that level of precision and speed, right?
It seems so. If you're paying for all those pre-machined materials before they even start assembly, that money has to be secured and delivered up front. That's the major operational constraint then.
That appears to be the case, yes.
Okay, beyond the cost structure, is there any tangible design constraint imposed by this panelized system? Anything architects need to know?
There is one main one that architects and designers absolutely need to be aware of: All wall lengths, they must be designed in 6-inch increments.
6-inch increment.
Yeah. So you can design a wall that's exactly 10 feet long, or 10 feet 6 inches long, but you cannot accommodate a dimension like 10 feet 3 inches.
So no odd inches.
No odd inches. It's a discipline that's necessary, really, to maintain the precision and efficiency of the factory machining process.
Got it. Okay, let's quickly circle back to the why not factor. If this system is so resilient, so fast, potentially so superior, why isn't it everywhere? The sources contrast Lifestone specifically against two other common alternative building methods, ICF and SIPS.
Right, and this comparison is crucial because it really highlights Lifestone's core non-organic advantage. First, ICF insulated concrete forms. Now, ICF provides pretty good insulation, but it relies on absorptive concrete blocks. Concrete, well, it absorbs and holds water.
And where there's water.
Mold and mildew can often follow, which can compromise indoor air quality over time. Lifestone uses no concrete blocks in the walls, just potentially in the foundation, and those stone coatings are designed to be waterproof. Big difference.
Okay, so that's ICF. What about SIPS? Structural insulated panels. Those are generally seen as a pretty fast, high-performance option too.
They are, but SIPS typically relies on wood, specifically OSB-oriented strand board, to create that structural sandwich panel.
And wood is organic.
The wood is organic. So in high humidity or flood-prone environments, think Florida, the Gulf Coast, anywhere damp, wet OSB will eventually start to rot, decompose, potentially delaminate.
Right.
The Lifestone system claims to eliminate all organic compounds from the exterior shell itself. That means the core structure fundamentally cannot rot, it can't delaminate, and it won't support mold growth.
That seems like a major long-term advantage, especially in disaster-prone areas. So if the upfront cost at 50% down is high, what's the long-term cost-value proposition? Why would someone invest in this?
It really comes down to two main things: utility savings and potentially insurance savings. That R40+ wall system is designed to cut electrical costs significantly, potentially up to 60%.
60% savings on electricity. That's huge over the life of a mortgage.
Huge. And crucially, because the structure has a Class A fire rating, it's engineered for those 250-mile-per-hour winds, and it resists flood damage. You are potentially looking at significant savings on long-term homeowners' insurance premiums.
Which are skyrocketing in many high-risk areas.
Exactly. The structure is built to last, as they say, many, many generations, and they're designed from the ground up to be net zero and off-grid ready if the owner chooses to go that route.
And just for the listener wondering about aesthetics, you're not locked into some kind of weird sci-fi bunker look, are you?
No, not at all. The exterior StuccoMax coating can be finished in pretty much any traditional stucco style you like: smooth finish, Santa Barbara finish, sand finish, whatever.
Okay.
And the interior PlasterMax, it's a natural, kind of elegant, off-white limestone color that apparently is often just left unpainted because it looks good on its own.
So the durability is fused with customizable aesthetics.
That's the idea. A combination of serious strength and conventional beauty designed to last a very long time.
All right, so to summarize this deep dive then, we've analyzed the Lifestone panelized construction methodology. It's built entirely from non-organic, relatively simple materials.
Yeah.
Steel, foam, and limestone coatings.
Right.
This allows for the rapid, engineer-driven assembly of a highly resilient structure that claims resistance to 250 miles per hour winds and major flood damage, all while potentially providing significant long-term utility savings.
And the main trade-off for all that speed and precision seems to be the requirement for a significant upfront financial commitment from the homeowner.
The 50% down payment hurdle.
Exactly. What really stands out here, though, is the elegant combination of ancient and modern tech. You've got limestone and steel materials used successfully for centuries, even millennia in limestone's case.
Right.
Combined with 21st century precision manufacturing. Every component is computer machined, labeled, shipped in a standard container. This aims to bypass so much of the typical variability and uncertainty associated with field construction quality and, well, competence. It's engineered consistency. And that leads us perfectly to our final provocative thought for you, the listener, to consider.
Given that this Lifestone system allows for the core structure of what is essentially a bulletproof, fire-resistant, 250-mile-per-hour wind-rated home to be shipped in a single container and then rapidly deployed pretty much anywhere domestically or internationally.
Right.
Does this level of material science and this rapid deployment capability fundamentally shift the future of housing? Does it move housing from being just a static, locally sourced commodity to becoming a globally scalable, disaster-proof structural asset? Something to think about.